Good day. For today's video, I am going to answer all the activities here in chapter 6. The first activity is entitled IP characteristics instructions. Reach each IP characteristic, then click connectionless, best effort, or media independent to indicate its delivery method. The first IP characteristic is fiber optics cabling, satellites, and wireless can all be used to route the same packet. I think this is in media independent. We'll adjust the size of the packet sent depending on what type of network access will be used. I think it is also in media independent. Does not guarantee that the packet will be delivered fully without errors. I think this is in best effort. No contact is made with the destination host before sending a packet. I think this is in connectionless. Will send a packet if the destination host not able to receive it. I think this is in connectionless. And the last is packet delivery is not guaranteed. I think this is in best effort. And all of them are correct. I will discuss. Characteristic of the IP protocol. Characteristic of IP. IP is the network layer service implemented by the TCP or IP protocol suite. IP was designated as a protocol with low overhead. It provides only the functions that are necessary to deliver a packet from a source to a destination over an interconnected system of networks. The protocol was not designed to track and manage the flow of packets. This function is, if required, are performed by other protocols in other layers. The basic characteristic of IPR: connectionless, best effort, it is unreliable, and media independent. Connectionless, no connection with the destination is established before sending data packets. Best effort, packets delivery is not guaranteed. Media independent, operation is independent of the medium carrying the data. IP connectionless. The role of the network layer is to transport packets between hosts while placing as little burden on the network as possible. The network layer is not concerned with or even aware of the type of communication contained inside of a packet. IP is connectionless, meaning that no dedicated end-to-end connection is created before data is sent. Connectionless communication is conceptually similar to sending a letter to someone without notifying the recipient in advance. IP, best effort delivery. IP is often referred to as unreliable or best effort delivery protocol. This does not mean that IP works properly sometimes and does not function well at other times, nor does it mean that it is a poor data communications protocol. Unreliable simply means that IP does not have the capability to manage and recover from undelivered or corrupt packets. This is because while IP packets are sent with information about the location of delivery, it contains no information that can be processed to inform the sender whether delivery was successful. There, there is no synchronization data included in the packet header for tracking the order of packet delivery. There are also no acknowledgments of packet delivery with IP, and there is no error control data to track whether packets were delivered without corruption. Packets may arrive at the destination corrupted, out of sequence, or not at all. Based on the information provided in the IP header, there's a capability for packet retransmissions if errors such as this occur. If out of order or missing packets create problems for the application using the data, then upper layer services such as TCP must resolve these issues. This allows IP to function very efficiently. If reliability over were included in communication, IP media independent. The network layer is also not burdened with the characteristic of the media on which packets are transported. IP operators operates independently of the media that carry the data at lower layers of the protocol stack. This is the second activity in chapter 6, which is entitled IPv for header fields. Instructions. Read, read each IPv4 functions and then click the IPv4 header field to which it belongs. The first one is identifies the priority of each packet. This is on differentiated services. Identifies the IP address of the receipt host. I think this is destination IP address, commonly referred to as hop count. This is time to live. Always set to 0100 for IPv4. I think it is inversion. Identifies the IP address of sending host. I think this is in source IP address. Identifies the upper layer protocol to be used next. This is in protocol. All of them are correct, so I will explain some of them. An IPv4 protocol version 4 packet header or IPv4 packet header contains application information including usage and source or destination addresses. IPv4 packet headers contains 20 bytes of data and are normally 32 bits long. A packet is a network communication data unit containing fixed or variable lengths. A 20-byte header contains almost 13 multi-purpose fields which hold specific related object information such as application, data, type, and source destination addresses. Version. This contains to the Internet header format and uses only 4 packet header bits. Source IP address. It stores source IP addresses. Destination address. It stores destination IP address. This is the third activity in chapter 6, which is IPv6 header fields. Instructions. Read each IPv6 header description and then click the IPv6 header field to which it belongs. The first one is always set to 0110. I think this is on version. Classifies packets for congestion control. This is on traffic class. To suggest that all packets receive the same type of handling by IPv6 routers. Identifies the application type to the upper layer protocol. This is in next header. When the value reaches 0, the sender is modified that the packet was not delivered and identifies the size of the data portion of the packet. All of them are correct, so I will explain some of them. Internet Protocol version 6 or IPv6 header. IP version 6 is the new version of Internet Protocol, which is way better than IPv4 in terms of complexity and efficiency. Version or 4 bits indicates a version of Internet Protocol which contains bit sequence 0110. Traffic class or 8 bits. The traffic class field indicates class or priority of IPv6 packet, which is similar to service field in IPv4 packet. It helps routers to handle the traffic based on priority of the packet. If congestion occurs on router, then packets with least priority will be discarded. Flow label or 20 bits. Flow label field is used by source to label the packets belonging to the same flow in order to request special handling by intermediate IPv6 routers such as non-default quality of service or real-time service. In order to distinguish the flow, intermediate router can use source address, destination address, and flow label of packets. Payload length or 16 bits. It is a 16-bit field indicates total size of the payload, which tells routers about amount of information a particular packet contains in its load. Next header or 8 bits. Next header indicates types of extension header immediately following the IPv6 header. The last one is hop limit or 8 bits. Hop limit field is same as TTL in IPv4 packets. It indicates the maximum number of intermediate nodes IPv6 packet is allowed to travel. Its value gets decremented by 1 by each node that forwards the packets, and packets is discarded if value decrements to 0. This is used to discard the packets that are stuck in infinite loop because of some routing error. This is the fourth activity in Chapter 6, which is entitled Identify Elements of a Routing Table Entry. Instructions. A particular router routing table entry is shown. Each section of the entry is identified by a circled letter above it. Select the correct routing table entry section for each output. Number 1. The elapsed time since the network was discovered. I think this is letter E. The the administrative distance or source and metric to reach the con, remote network. I think this is letter C. How the network was learned by the router. This letter A. Shows the destination network. This letter B. The next hop IP address to reach the remote network. This letter D. The outgoing interface on the router to reach the destination network. This letter F. Let's check. All of them are correct, so I will explain. A routing table is a set of rules often viewed in table format. That is used to determine where data packets traveling over an internet protocol or IP network will be directed. A routing Basic routing tables include the following: destination, next hop, interface, metric, and routes. The IP address of the packet's final destination. This is destination. Next hop, the IP address to which the packet is forwarded. Interface, the outgoing network interface the device should use when forwarding the packets to the next hop or final destination. Metric assigns a cost to each available route so that the most cost-effective path can be chosen. Routes include directly attached subnets, indirect subnets that are not attached to the device but can be accessed through one or more hops, and default routes to use for certain types of traffic or information in logging. This is the fifth activity in Chapter 6 entitled Identify Router Components. Instructions. Description of router function and hardware parts are provided in the table. Drag each router component name to its function or description. The first description is connects routers to external networks, usually over a large distance. I think this is one interface. A way to remotely access the CLI across a network interface. This is Telnet or SSH. Connects computer, switches, and routers for internal network. This is LAN interface. A local port uses USB or low-speed serial connection to manage network devices. This is console port. And the last one is a port to manage routers using telephone lines and modems. This is AUX port. Let's check. All of them are correct, so I will explain. A one interface card or WIC is a type of specialized network interface controller card made by Cisco that allows a network device such as a router to connect and transmit data over a wide area network. Telnet or SSH. Telnet is a network protocol that allows a user to communicate with a remote device. It is virtual terminal protocol used mostly by the network administrator to remote access and manage devices. The SSH is a network protocol used to remotely access and manage a device. The AUX port allows a direct network connection to the router from a remote location. A network interface allows a computer or mobile device to connect to a local area network using internet as a transmission mechanism. Every Cisco router or a switch has a console port, also known as the manage port, on its backside. Console port is used to connect a computer directly to a router or switch and manage the router or switch since there is no display device for a router or switch. This is the last activity in Chapter 6 entitled The Router Boot Process. Instruction: drag each of the steps on the left to appropriate field in the table on the right to show the router boot process order. Step 1. I think this one. Perform POST, like hardware check performed by built-in room chip. The step 2 is load bootstrap copied from our room to RAM locates the iOS. Step 3. Load the iOS or operating system file for the router loaded into RAM after Bootstrap finds the iOS file to be used. And the last step is load the configuration file from flash NVRAM, a TFTP server, or go into setup mode to create a configuration file. All of them are correct, so I will discuss. Router boot up process. The power on self-test or POST is a process which occurs on almost every computer during boot up. This process is used to test the router hardware. When the router is powered on, software on the ROM chip performs tests on several hardware components such as CPU, RAM, and NVRAM. And that's all for today. Thank you for watching. God bless.